various types of energies out there. Potential, kinetic,
But today we're going to be talking about a very special kind of energy, if I do say so myself. It's not one that, immediately comes to mind when you think of equations, figuring out sorts of energy and stuff, but it's very important because it does explain why energy is seemingly lost. It's very important. And that energy that we're going to talk about today is thermal.
Now, there are a couple types of energies you're already familiar with. Potential, kinetic. But today we're going to be doing some demonstrations on thermal energy.
You could just refer to some boring note cards about all of this information, but why would you when you have this?
First up, we have a ball. Now, the ball is a perfect demonstration of how both potential and kinetic energy can be converted into thermal energy. Notice how when I drop this ball, it does not come back up to the same height as when I dropped it from. That is because the ball is experiencing friction caused by air resistance with the air particles it comes into contact with. This is slowing the ball down, and in addition to that, it's taking away from the potential energy it had when I dropped it. That's why it doesn't come back up to my hand. In a perfect physics world, in which friction isn't a thing, that wouldn't happen. But thanks to friction and thermal energy, that's what happens. Observe what happens when I drop this tin from this height. Notice how it didn't come back up to the same height. This is because of the air resistance caused by the air. Now, another thing you'll notice here is if you listen very closely, you'll hear a small whooshing noise. Now, this whooshing noise is being caused by the wire, but it's mostly being caused by this orange thing because of how much surface area it is applying to the air. This is also another way in which energy is lost, is through the creation of sound.
Let's talk a little bit about thermal energy. Thermal energy is generated by the kinetic energy of the particles within an object. Work done by friction results in thermal energy because friction causes the bonds between molecules to stretch and warp, and when they return to their original position, energy is released as heat. Let's take a look at this hyper-realistic skateboarding simulation. As you can see, as the skateboarder goes across more of the surface, thermal energy accumulates. Unlike kinetic and potential energy, it doesn't depend on the position above the ground, and it doesn't increase and decrease. It just increases over time. Thermal energy takes up a larger and larger portion of the total energy as the skateboarder continues to rip it up on the track. Now, if I were to drop the skateboarder from the sky like a vengeful god, the collision with the board and the ground would produce a lot of thermal energy at once because of the severity of the collision. The more force behind it, the more thermal energy it creates. That's why rubbing your hands to keep them warm only works if you do it quickly and intensely. Hello, focus, go.
There's many kinds of energies out there. Fuck.
Let's try one more time. Whenever you're ready.
There's many kinds of energies out there. Potential, Kinetic. Wait, hold on. Don't touch the ground. Shit. Alright, we're good. For several reasons. But the main one is because of thermal energy. If you listen very closely, very, very closely, it's very quiet because there isn't too much resistance. There's a small whooshing noise being made by this wire and this orange thing as it comes into contact with the air. This sound energy, these sound vibrations,
Is not thermal energy, which is what you
is
segued.
created
Yep.
by thermal energy.
Is it?
I assume? Is it not?
Da-da-da.
Now, watch what happens when I release this thing.
That was so lame.
It really was. Okay. I'm gonna squat. Just for a little bit. Just for a
How
tiny-
about you say, like, watch what happens when I, like, swing it? I don't know.
I got it. I know what.